Yes, so I hope my screen is visible to everyone. Yeah, so this is lecture 15 on computer networks, and in the previous
Yes, sir.
lecture we were discussing options. I hope so. Let me check that out. Yes, we were discussing options. Okay, options in IP header. I have told you there are two types: single byte and multiple byte. Single byte were no operation and end of operation, or and no operation and end of option. Okay, and multiple bytes are these. So record route, I think I have told you about. It can remember up to 9 routers addresses. Okay, we have told you that thing in the previous lecture. So now we have to study strict source route, loose source route, and timestamp. Okay, total 3 are left out. So let me start today's lecture. So first is strict source route, or SSR. SSR, that is strict source route. Okay, strict source route. So this means that this is sender, and there are multiple routers in between, and we have a receiver. Okay, so sender will decide the route, that from which path packet should follow. Okay, so decide the route, and it will put IP addresses of the router to from which packet will go. Okay, so decide the route and put IP addresses of routers. Okay, so it will put IP addresses. Okay, now it will start from the sender. Packet will start from sender. Okay, it will move to this router. So now if this router is in the list, or you can say IP address of this router is in that list, okay, then only it will forward the packet, otherwise it will discard the packet, and ICMP error message will be sent to the sender. So it's very simple. Sender is deciding the route. It will put IP addresses of all the routers. So all those routers must be visited by the packet. But packet cannot not neither less nor more. Okay, less is not allowed, more is also not allowed. Less means you cannot skip any router. Less means skipping is not allowed. More means you cannot visit any extra router. Extra router cannot be visited. Okay, so as the name says, strict, that means it is very strict route. Okay, that means source will decide it, and it will put IP addresses of the routers in the header itself. Okay, and if router has received a packet, if this router it will see the IP addresses, that whether my IP address is in the list or not. If its IP address is not in the list, it will simply drop the packet, and it will send ICMP error message to the sender. Okay, so I hope you have got the point. Strict means it is very strict, neither less nor more. That means skipping is not allowed. You cannot skip any router. More, that means you cannot visit any extra router also. Okay, so if 5 routers are there in the list, you have to visit all the 5. You cannot skip anyone, and you cannot visit any extra router. That is the basic meaning here. Okay, so why we are using SSR? Just to implement any particular mechanism, like I have told you, na, DTRC, minimum delay, maximum throughput, maximum reliability, minimum cost, and so on. So if you want to say you are sending your credit card number to somebody, so you want maximum reliability. So for maximum reliability, you will decide that okay, my packet should go from to these routers. If it visit any other router, that means you will say no, I will discard the packet, and so on. Okay, so to send confidential data and so on, we can use it. So directly I want to say, if you want to use any particular service of IP, then we will use this SSR. Is it okay?
Yes, sir. Clear, sir.
Yeah, so you can take the snapshot. I will jump to the next slide. If you want, then I can dictate few notes, otherwise it's okay.
It's okay, sir.
Okay, then good. Let me jump to the next slide. So basic thing is neither less nor more. Okay,
Yes,
next
sir.
is next is LSR, or loose source route. Loose source route, as the name suggests, it is less strict. Okay, it is giving you some reliability, or you can say some relaxation. That's why we're calling it as loose source route. Okay, so what is the relaxation? So skipping is not allowed. Skip is not allowed, but more is allowed. Okay, that means a packet can visit some extra routers, it is allowed. But if if in the list we have 5 routers, so you have to visit all the 5 routers. You cannot skip them. Okay, you can visit some extra also. That is the basic difference between LSR and SSR. Okay.
Yes, sir.
So take the snapshot. I will jump to the next slide.
Done, sir.
So LSR and SSR are similar. One and the same thing, basic meaning. The only thing is in LSR, skipping is not allowed, but you can visit more routers. And here, skipping is not allowed, and more also not allowed.
More routers are not allowed.
Take the snapshot. I will jump to the next slide.
Done, sir.
Okay. Next is timestamp. Last option is timestamp. So you should know just one, two lines of each of these. Okay, that is more than sufficient. If they will ask, then they can ask MSQ only from this topic. Okay, timestamp. Timestamp. I think you have got it. It is used to store the time of the time. You can say time of the datagram processing. Okay, we should say precisely. Timestamp mean time of datagram processing. Datagram processing. Okay, so this timestamp option is basically used by forensic department. Okay, so in many murder cases and all, they will see that the router was switched on at that time, router was switched off at that time. So there might be some person in the room who has switched off and on the router, and email was sent at this amount of time. That means you have operated the computer, so that means you have done something and so on. So for murder cases and so on, forensic department use these things. Okay, so you can see the timestamp when router has processed the packet. That is the basic thing. So if you have sent email to somebody, your router at your home, that must have processed the packet, only then it has sent to the internet, na? So that time will be recorded in the router. Okay, so you can check that out with the help of this option. Okay, so timestamp means time of datagram processing. Okay,
Yes.
will be recorded. Okay, time of datagram processing recorded. That's it. Roughly, I'm telling you, more than sufficient. It is not required that much. Take the snapshot. I will jump to the next slide.
Done, sir.
Okay, so this is all about timestamp. So now our option topic is completed. So now we will start the 4 supporting protocols of IP. That is also very important. Many questions have been asked. 4 supporting protocols of IP. Okay, if you try to remember, I have told you there are 4 supporting
Yes.
protocols.
Yes.
What are these? ARP, RARP, ICMP, and IGMP. Okay, there are 4 protocols. Okay, so one by one we will study. First is ARP. Let me start that. Take the snapshot.
Done, sir.
Okay, so ARP is Address Resolution Protocol. Address Resolution Protocol. So what it will do? This is sender. These are the 2 routers, and this is the receiver. Sender wants to send packet to receiver. Okay, so obviously datagram cannot fly away. It has to be packed in frame. Okay, for example, this is a datagram. Now this datagram will be packed in frame. That means header and trailer will be attached, and this frame will be transferred to this router. This router will transfer this frame to this, from here to here. Okay, so hop to hop. The DLL work is hop to hop. Network layer was from host to host, and end-to-end delivery was of transport layer. I think you already remember these things. Okay, so now basic thing is sender knows IP address of this router. Okay, sender know IP of R1 to which it wants to send the frame. Okay, because see, the basic idea is sender wants to send a datagram to receiver. Let me write it. Sender want to send datagram to R to the receiver. Okay, now datagram cannot fly. Datagram will be packed in frame. So since it will be packed in frame, and sender knows IP address of R1. Why it knows IP address of R1? Because it has a routing table and all. We will study that thing in in today's lecture. I hope if we reach that point, then we will get to know about it in today's lecture only. Otherwise, we will start that in next lecture. But the basic thing is that you should suppose that sender knows IP address of R1. Okay, but it does not know the physical address of R1, and if it does not know physical address, then how this frame will be transported to the to R1? That is the biggest problem. So now I want to say that sender knows IP address of R1, and it wants to know physical address of R1. So what protocol will be used? ARP will be used. Okay, similarly R1 knows IP address of R2, but it does not know physical address of R2. And why it wants to know physical address? Because datagram cannot fly. It has to be packed in frame, and then frame will be transferred to R2. Similarly, R2 knows IP address of R. That is very, very simple. How it knows? You can check it out from the you can say datagram itself. Okay, sender and receiver both IP address will be there. So R2 router knows IP address of receiver, but it does not know the physical address. So again, ARP will be used. So they can ask the question, how many times ARP will be used? One time, second time, third time. So ARP will be used 3 times here in this scenario. Any doubt here?
Yes. Nice, sir. Understood.
Okay. And what is the use of ARP? Use of ARP is it is used to map IP address to physical address. Okay, that means sender knows IP address but does not know physical address. So it wants to know the physical address. That's why we are using ARP. Please do not use the word convert. IP address cannot be converted to physical address. Okay, we are not doing some mathematical kind of thing. We are not converting one number to another number because actually they are numbers only. IP address is a number, physical address is also a number. So we are not converting numbers. Okay, we are not doing mathematics. We are not doing addition, subtraction, and so on. We cannot convert. We will say we are going to map. Okay, so mapping of IP to physical address, that is done by ARP. Let me write it. So IP to PA or LA to PA mapping. Okay, LA IP is logical address, na? So LA to PA mapping. LA to PA mapping. This mapping is done by ARP. Okay, now briefly let me tell you how this ARP will work. Take the snapshot. I will jump to the next slide.
Done, sir.
Okay. So how this is done? Let me tell you. See, this is the sender and this is the router R1, and sender wants to know sender know IP address of R1, but it does not know physical address. So what it will do? It will send ARP query packet. This question has been asked in GATE. ARP query packet. Okay, now in ARP query packet, since it does not know physical address of R1, so in destination physical address, what it will write? In source physical address, it will write its own physical address. For example, A B dot 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 something might be there. Okay, so it will just a second. Actually, somebody is calling me. Just a second. Yeah. Yeah, so what we were studying, so ARP query packet. So as source physical address will be whatever may be the physical address of the source. Destination will be, since it does not know, it wants to query, so it will put all ones. FF 48 bits na, FF and FF. So 1 2 3 4 5 and one time more, 6. So 6, yeah. So 8 bits. So 8 is the 48 bit. This is your destination physical address. Why I am keeping all ones? Because I do not know. Since I do not know, so I want to send query packets. So obviously it will be broadcasted on the entire network. Okay, so you have to remember ARP query packet is always broadcasted on entire LAN. On entire LAN. So each and every you can say receiver will receive it. So there are multiple computers attached here. So all of them will receive it, and obviously all of them will you can say ignore, because this sender wants to know IP address of physical address of R1. Okay. So IP address will be of R1 only, na? Because it knows the IP address. Okay, so that's why they will ignore, and only this R1 will you can say get the packet, and it will send the reply. Now for reply, since sender has sent its own physical address in the packet itself, so reply will be unicasted. So ARP query packet is broadcasted on entire network, and ARP reply is unicasted. Okay, ARP reply is unicasted. ARP request packet is broadcasted. Okay, I hope you have got the point. This question has been asked, which is broadcasted, query or reply? Query is broadcasted, reply is unicasted. Why unicasted? Because we have source physical address in the packet itself. Any doubt here?
Understood, sir.
Okay, so that's it. This is all about ARP, and we are not going into unnecessary detail that how this what is the format of the packet. Okay, there are lots and lots of things in here, but we are not digging deep into it because it is not required for GATE. Like what is the format, how this query packet look like, and so on. We are not going into unnecessary details. It is not required for GATE. That is more than sufficient. Whatever I have told you, ARP query packet is broadcasted and ARP reply is unicasted. And what is the use of ARP? ARP use is very simple, LA to PA mapping. That's it. Okay, so you know a logical address of any machine and you want to know its physical address. Which protocol you will use? ARP. This question has been asked in GATE. Okay, we know logical address of any machine and we want to know its physical address. What protocol should we use? ARP should be used. Okay.
Done, sir.
Okay, so you can take the snapshot. I will jump to the next slide now.
Done, sir.
Okay, yeah, another important point. ARP, you should know that ARP is used till now. That is, it is not like that it is obsolete and so on. We are not using it. Day by day technologies are changing, but ARP is still used. You should know this thing. ARP is still used nowadays. Is still used nowadays. That means it is not obsolete. Okay, it is not like that it is obsolete. It will give you the basic difference. The next protocol will be RARP. RARP is obsolete. It is not used nowadays, but ARP is used. Okay, so ARP is still used nowadays. You should know this thing. And one more thing I want to tell you. So for example, I have told you na, in destination physical address we have all ones, and I have told you all ones packet will never cross any router, because if it cross one router, then it can cross and all the routers in the internet, and obviously congestion will occur in the entire internet. Okay, so we have a rule that packet will never cross any router. Okay, if packet has all ones as physical address or IP address. Okay, so now see this. We have a computer A here, B, C. Okay, and we have a router here, and here we have D, E, and F. So directly indirectly I want to show you subnetting kind of concept here. Okay, so in subnetting I want to say you what will happen. Let me show you that also. So A wants to know physical address of D. So I want to say A know IP of D and want to know PA of D. So obviously A will send query packet. So query packet will reach this router. So I think you have got the point that destination physical address will be what? All ones. So all one means what? It will be dropped by the router. Okay, so directly indirectly A cannot know physical address of D. Okay, so but if we have used subnetting, that is for sure. If they are in different network, you cannot know, because router will drop the packet. Okay, so let me tell you that thing. If two systems are in different network, if A and B are in different network, then ARP query packet cannot be used. Okay, then ARP query packet will be discarded by the router. Will be discarded by router. Okay, so directly indirectly I want to say that you cannot query any system, or you can say you cannot query any system physical address if it is not in your network. If it is in different network, you if it is in different network, then you cannot query IP address. Okay, so for example here you might say, sir, why you are doing in this in 3 times why ARP is used? Directly sender should know the IP physical address of receiver, and it can send frame to itself to R and so on, but we cannot do like this. Okay, so it is just for security reasons. So if two machines are in different network, okay, then you cannot know physical address of other machine. That is the basic thing. Okay, now but if you have used subnetting means in the your network itself has been divided into small subnets, then obviously you should be able to send. Are you getting it? See this, if one machine is in this network, one machine is in this network. Okay, so now you cannot know physical address of this machine, because in between there should be router, and router will drop the packet. But if you have a one big network and you have made small subnets of this network, that means subnetting you have used. So then if A wants to know physical address of D, then it should be allowed. Okay, it should be allowed, because for big network you have made small subnets, so it should be allowed. Okay, so in that scenario we will use proxy ARP. Let me write it. We will use proxy. Let me tell you that thing in the next slide. Take the snapshot. Done.
Done, sir.
So now I want to tell you proxy ARP. Proxy ARP. Proxy ARP means in case of subnetting, you should know this question has been asked, and this is very important difference also between ARP and RARP. In case of subnetting, ARP can be used. ARP can be used. Okay, that means see this. So if we have a system A, B, C, and here we have a router, and here we have D, E, and F. So proxy means, I think you already know, na? In colleges, student do proxy kind of thing, na? You are doing proxy of somebody. That means you will raise your hand and you will say present and so on.
Yes,
So
sir.
that person might not be present, and you are saying his or her presence. That is proxy. So same is the scenario here. So A wants to send message to D. So it wants to know physical address of D. So it will send query packet, and router will see this, and router will say, in place of replying D, router will reply in place of D to A. That means router will send its own physical address to A, and A will send message to this router, and router will forward it to D. So everything is done with the help of router. So D presence is given by this router. That's why we're calling it as proxy ARP. Are you getting it? So router will we will configure this router to do this kind of thing. So what it will do, it will first check that okay, all ones are there. So it will check whether it is ARP query packet or not, because all ones means packet will be discarded by the router. So we will configure this router. Okay, and in place of sending and router already know that D is connected to me. So router will announce its physical address to A. Okay, and A will send message to this router, and router will forward it to D. So D should give his or her presence. D should give his presence, because A wants to know D physical address. So D should reply, na. But in place of replying D, router is replying. That's why we're calling it as proxy. Okay.
Yes,
So
sir.
this is more than sufficient. So you should know one thing only. We should not dig deep into this implementation detail. One thing you should know for MSQ: in case of subnetting, ARP can be used. That's it. Bas. This is more than sufficient. Okay. In case of subnetting, ARP can be used. More than sufficient. And what we are doing? You have got it. Router will send its own physical address to A. A will send message to router. Router will send to D. That is the basic thing. Okay. Hmm.
Yes,
Take the
sir.
snapshot. I will jump to the next slide.
Okay, sir.
Hmm. So this is all about proxy ARP. Next is RARP. RARP is reverse address resolution protocol. RARP is reverse. Reverse means ulta, एकदम ulta करेंगे आप. Okay, reverse address resolution protocol. ARP I have told you. So I'm not writing again. Address resolution protocol. Reverse address resolution protocol. So what it will do, as the name says, it will do the reverse kind of thing. What ARP was doing? LA to PA mapping. LA to PA mapping. That means you know logical address of any machine and you want to know its physical address. What RARP will do? What RARP will do? Physical address to LA mapping. Okay. And now in this case, what we want to say, you know your own physical address, but you want to know your own logical address. So this is the basic difference. Okay. So this means you know logical address of any machine and you want to know its physical address. Then you are using ARP. For RARP means you know your own physical address. You know your own physical address and you want to know. Okay. You know your own physical address and you want to know your own logical address. So what you will use? RARP. This question is very famous. Many times it has been asked. Whenever diskless machine is booted and machine knows its physical address and it wants to know its logical address, which protocol will be used? Let me write it. Very, very important. Many times this has been asked. Whenever diskless machine is booted, whenever diskless machine is booted and it knows its own physical address, but it knows physical address and it wants to know logical address. Okay, which protocol? Shortly I'm writing which protocol should be used. RARP. This question has been asked directly or indirectly many times in GATE. So whenever diskless machine is booted and it knows its own physical address and it wants to know logical address, which protocol will be used? RARP will be used. Diskless means hard disk is not there. Okay, it has been booted from the server. Okay, so like in I think you have seen in your in many colleges. Okay, so we have in computer labs, hard disk is not there in CPUs. Okay, so
We
they
have
are
thin
booted
clients now,
directly.
sir.
Yeah, please come again.
We have thin clients now, sir.
Yeah, yes. So we have hard disk is not there, so they will boot from the server itself. Yes. Okay, so whenever diskless machine is booted and it knows its physical address and it wants to know logical address, which protocol will be used? RARP will be used. This is very important question. Okay, so now question arises, why this machine wants to know logical address? Of course, it wants to send IP datagrams or it wants to connect to internet. Okay, that's why it wants to know its logical address. That is very obvious now. Why it wants to know? Because it wants to connect to internet. Because it wants to connect to internet. And if you want to connect to internet, obviously you should know IP address. Without it, you cannot you connect it to connect to internet. And another reason can be it want to send datagram to someone. It want to send datagram. Okay, so in order to send datagram, obviously you should know your SIP. Datagram, I think I have told you, na, IP header, source IP address, destination IP address, both are there. So if SIP is not there, then how you will send the frame? So how you will send the datagram? Okay, source IP address you should know, na. Okay, so that means you should know your own IP address, because if you do not know your own IP address, then you cannot send the packet. That is very obvious. Okay, so now question arises that for ARP it was easy. Why? Because see, this is the sender and this is the router. Now this sender know IP address of this router R1, but it does not know physical address of this R1. So obviously R1 knows its physical address now, so it will send its physical address to sender. So obviously everything is fit and fine in case of ARP. But in RARP there is a different kind of scenario. What is the scenario here? We have a machine. Okay, we have a machine and it has just booted. Okay, and it knows its physical address. Physical address it knows. Why? Because it is hardware imprinted. Okay, in NIC card, network interface card, we have in you can see your CPU or CPU in LAN card, which you call, and network interface card. So on that LAN card we have a ROM, read only memory. In that ROM there is a physical address is present. Okay, so so whenever diskless machine is booted, so from NIC card it can read the physical address. So directly I want to say that machine knows physical address. And now problem is it wants to know its own LA. So who will keep his LA? Okay, so who will keep this much headache? Okay, how somebody will keep this much headache that that machine store logical address of this machine? Are you getting my point? This is very basic point. Sender want to send message to this router and it knows IP address of this router, but this sender does not know physical address of this router. Obviously this router knows its own physical address now. That's why it was able to reply to him and he was able to get the physical address. It was very obvious and very easy task. But here problem is little bit complex. Why it is complex? Because now this machine knows its physical address, but it wants to know its own logical address. So who will keep this logical address? Okay, who will keep this machine's logical address? Obviously that will be server. Okay, so it is not a normal machine, it should be a server. So very first difference is coming now. Please try to see carefully. In ARP they it is not based on client server model, but RARP is based on client server model. Why? Because obviously server will keep track of all the IP addresses of the machines. Okay, so I think you have got the point. So let me jump to the next slide and I will write the differences. Take the snapshot. Done. Yes. Yeah. Okay. Okay. So now basic difference between RARP and ARP. RARP and ARP. The very first difference, it is used for physical address to logical address mapping. That is rough idea. Actually what we are saying is you know your own physical address and you want to know your own logical address. Okay, that's why you are using RARP. ARP, it is doing the reverse process, LA to PA mapping. That means you know logical address of some machine and you want to know physical address of that machine. Okay, so for that you are using ARP. Next important point, ARP is not based on client server model, but RARP is based on client server model, because only server will know the IP addresses of other machines. Okay, so who will keep your headache that I should know your IP address and I should know your IP address? Nobody will keep that headache. Okay, so only server is the machine which will keep this thing in you can say in his or her computer. Okay, so it is based on client server model, RARP, but ARP is not based on client server model. Okay, next. So since it is based on client server model, so I think you have got it. If we have used subnetting, see this. This is a big network and you have created many subnets. So now since okay, so first of all you should know RARP request packet will be what? It will be broadcasted just like ARP. Okay, because now this machine wants to know its own logical address, it no physical address. So it will send a packet in which physical address is, okay, let me tell you that thing also. So SIP, DIP, source IP address, destination IP address, okay, and then source physical address and destination physical address. SIP, source IP address, it does not know its own IP address, so it will use 0.0.0.0. Try to remember, I have told you, whenever machine does not know its own IP address and it wants to know its own IP address, it will use as this IP address. In reserved IP addresses, I have told you, na? After IP addressing, I have started the reserved IP addresses. In that I have told you SIP will be this. Okay, DIP, destination IP address, it does not know, so it will put all ones, 255.255.255.255. Okay, what about source physical address? So source physical address it knows. Okay, so whatever will be that it will put. Destination physical address it does not know, so it will put all ones, FF, and so on. FF, dot all ones. Destination IP address is all ones, destination physical address is all ones, SIP is all zeros, and source physical address will be, it already know, whatever may be that, like A, B, C, D, E, F, whatever may be that, it knows and it will put that. Okay, so now this might be asked in gate, like in RARP query packet, what will be SIP? In RARP query packet, what will be DIP, and so on, they can ask, and obviously it will be broadcasted. So just like ARP, RARP query is broadcasted, query broadcasted. Okay, so that means all machines will receive it. Okay, and server will reply. Okay, server will reply. So RARP query packet is broadcasted and reply packet will be unicasted, that is for sure, because now you have source physical address. Okay, so it will reply will be unicasted. Query broadcasted, reply unicasted. This is a rule. Query always broadcasted, reply always unicasted. RARP reply unicasted. So same thing. Okay, let me write it. So next third it is not a difference kind of thing. On subnetting I will come back to it in 1 or 2 minutes. So RARP query broadcast reply unicast. Okay, so same is the case in ARP. Same is the case in ARP. Okay, both were same. Fourth difference is coming now, subnetting. Let me tell you that thing also. So yeah, so in case of subnetting, ARP it was successful because I have told you proxy ARP we can use, and it can be used in subnetting. But for RARP, what you have to do, since you have to install server, okay, so in each and every subnet there should be a server. So here also you will maintain one server, here also, and here also. So obviously that is not economical kind of thing. Why if you have one network and you have created 4 subnets, then in all these different 4 subnets you have to install 4 different servers. Why it is necessary? Because I have told you, see this, SIP is this, DIP is this. Okay, so all ones means router, it cannot cross any router, and whenever we have subnetting, router will be there, so it cannot cross the router. That is the biggest problem. Okay, and please do not think like in proxy ARP router was telling its own physical address to the sender, and sender was sending packet to router, and router was forwarding it. It cannot be done in RARP kind of thing. Okay, because you want to know your own physical address. How router will keep your physical address? If router is keeping your physical address, that means what? It is acting like a server. Any doubt here, or is it okay? Yes, please let me know. Okay, so I think there is some network issues. My voice is clear, na? Okay, so okay, so for RARP, what we were saying that uh, it cannot be used in subnetting. Okay, in subnetting it cannot be used, but ARP it can be used in subnetting. That is very important point. Okay, this has been asked in gate. Which protocol can be used in subnetting? ARP can be used, but RARP cannot be used. And in subnetting we are using what? Proxy ARP. Okay, proxy means router will reply its physical address. Okay, in place of replying, actual machine is not replying. In place of actual machine, router is replying. So router is replying on behalf of that machine. That means what? Router is doing proxy kind of thing. That's why we are calling it as proxy ARP. But this proxy kind of thing cannot be used in RARP. Next important point is RARP is obsolete nowadays. It is not used, obsolete. Okay, and this is used nowadays. Okay, it is used nowadays. Why it is obsolete? Why it is not used? Obsolete means not used. Why it is not used? Because it is not economical. Na? In subnetting you are not able to use it. That means what? You have to install multiple servers. Okay, number of subnets means number of servers. So it is not used, not economical, and it is not used. Okay, not used because not economical, or you can say multiple servers. You have to multiple servers needed in subnetting. Okay, whenever we are going to use subnetting, then we have to use multiple servers. That is the problem. Okay, yeah, you can take the snapshot. I will jump to the next slide. Done. Okay, so I hope you have taken it. Let me jump to the next slide now. So now since RARP is not used, so now question arises, which protocols are used nowadays? Okay, we want this thing na, PA to LA mapping. We want PA to LA mapping. Okay, so now which protocols are used nowadays? So now there are two protocols. Okay, let me write properly. For PA to LA mapping, there are three protocols: RARP, next is BOOTP, and next is DHCP. There are three protocols. RARP is not used nowadays. Even BOOTP is not used nowadays. DHCP is used. That is the most advanced. Okay, so let me tell you something about these three protocols. RARP we have completed properly. Now let me tell you about BOOTP and DHCP. And one more thing, we are studying network layer. RARP operates network layer. No problem at all. It is used at network layer only. But BOOTP and DHCP are application layer protocol. That is also very important. Many times question have been asked, which of the following is application layer protocol? BOOTP and DHCP are application layer protocol. So why we are studying that in network layer? Because their work is physical address to logical address mapping. That's why I'm covering here. Otherwise I have to cover them in application layer only. Okay, yeah, but you should know that these two are application layer protocols. Okay, so take the snapshot. I will jump to the next slide, and in the next slide I will tell you little bit about this BOOTP and DHCP. Done?
Yes, sir.
Okay. Okay, so now we are going to start BOOTP. BOOTP is bootstrap protocol. Bootstrap protocol. Okay, similar idea. We will not dig deep into it. I will just tell you that SIP same, DIP. Okay, source physical address, destination physical address. SIP will be 0.0.0.0. DIP will be 255.255.255.255. Source physical address, it will be it already know, A B C D dot dot dot, whatever it will be that, and destination will be all ones. Okay, so query packet will be made and it will be sent. Okay, it will be sent to the you can say on the network. Okay. Hmm. Mm, okay, just a second. Hmm. Okay, and yeah, and I want to tell you one more thing, that since it is boot P is application layer protocol, na, application layer protocol. So at application layer, query packet will be designed. We are not going into detail with how query will be designed and so on. After application layer, we have transport layer. Okay, so at transport layer which is used, so we should know this thing, that at transport layer UDP is used. Why UDP is used? Why UDP? Because we are simply sending a small query packet and we will get a reply of it. The TCP will be used in that case where we have a big message, application layer is creating a big message and we want to do chopping and so on. I have told you many times. Okay, so UDP will be used at transport layer. And this question I've been asked, boot P will use which transport layer protocol? It will use UDP. And you should know the port number also. Port number is 67. This number is very very important. Okay, port number I will tell you when I will jump to application layer. Now in application layer we have to study very few protocols like SMTP, simple mail transfer protocol, IMAP, okay, POP3, okay, and DNS. Okay, so total 5 protocols are there, 4 to 5 protocols. Don't worry, we will study them. And for each and every protocol, port number has been asked many times in match the following: SMTP which protocol, IMAP which protocol, POP3 which protocol, okay, DNS which protocol, and so on. They will ask this thing. Okay, and I will tell you about style also, how to learn this. POP3, 3 means 3 is binary is 011 na? So you just reverse it, 110. So 110 is the port number of POP3. Okay, so don't worry, I will tell you style how to remember all the port numbers, and these are very very important. In match the following they will ask. Okay, so you should know this thing. At transport layer UDP is used and port number is 67 for this bootp protocol. And then after transport layer we have network layer. At network layer we will use SIP as all zeros and DIP we will use all ones. Okay, okay, oops. Let me copy it out. Yeah, this is done at network layer. Okay, and then we have data link layer. At data link layer we will use this. Okay, at DLL we will use it. Okay, so now I think every now picture is clear properly. Application layer, this is APP, application layer query packet. Forget about format, how it is designed and so on. It is not required for gate. Now after application layer we have transport layer, that will be asked in gate. At transport layer UDP will be used. In which protocol which port number? 67 port number. And which protocol? UDP. We have two choices, UDP or TCP. So I have told you na, whenever you want to send small messages, UDP is the best. Whenever you want to send large messages, chopping should be done, then in that scenario we will use TCP. Okay, so here we do not need TCP now, we are just simply sending query packet, very small packet, so UDP is used. At network layer SIP will be all zeros, DIP will be all ones. At data link layer source physical address you already know, destination physical address will be all ones. Okay, so now same problem na, it cannot cross the router. That was the problem with RARP, and here also same problem, it cannot cross the router. So what we will do now, listen carefully. This is the machine A, okay, and here is the router, and here let us suppose we have installed the server. Okay, so now this router obviously will drop the packet now, because we have all ones as IP address. So now we will configure this router to work as relay agent. Relay agent. Okay, what relay agent will do? Relay agent, that means now router will work at application layer. Okay, now router is working at application layer. That means we have configured the router to work at application layer, and we call them as relay agent. Relay agent will come to know about, okay, this is a query packet, and now it will send that you can say query to the server, and server will reply, and finally server will reply to router, and router will reply you. Okay, that means this is your IP address and so on. Okay, and one more thing I want to tell you, that we have configured router to work at application layer. Okay, why we have configured it? So that it know at application layer what was the message. Okay, let me tell you a basic scenario so that you get more clarity. If we have any device, for example, say, okay, let me tell you that router. Okay, router work at network layer. Router work at network layer. This means that router has idea about IP address. What is the IP address in the packet? It knows. Physical address, it has idea. And about signal. Signal is the at physical layer, it has idea. So router has idea of all these things. What is the IP address of the pack? What is the IP address in the packet? What is the physical address? What is the signal? And so on. It knows everything. Okay, and we have bridge. Okay, actually it is not required, but I'm just telling you so that you get more clarity. Bridge work at data link layer. Since it works at data link layer, so it knows about physical address, it knows about signal, but it does not know about IP address. What is the IP address in the packet and so on? It does not know, because bridge scope is at data link layer only. Okay, similarly we have concept of gateway. Gateway work at all the 5 layers. Okay, so that means what? It is an application layer device. Application layer device. So obviously it know about message also, what message you are sending and so on. It can see it properly. So if I talk about router have idea only about IP address, physical address, signal. It does not have idea about port numbers. Okay, because port numbers are used at transport layer, and it does not have idea about message, what exactly message you are sending. Bridge has idea about physical address and signal. It does not have idea about logical address, what IP address was there, port numbers what were there, message what was there. It does not know anything. Okay, gateway is an application layer protocol, so it has knowledge about message also, so obviously it has knowledge about port number also, logical address also, physical address also, and the signal also. It has knowledge about everything. That is gateway. Okay, and if we are using say any hub or passive hub and so on, hub, if we are talking about hub has knowledge about signal only, because it is a physical layer device. So device which is working at respective layer, that device will have knowledge about that thing only. Like physical layer, that means hub will know about signal only. It does not have knowledge about physical address, it does not have knowledge about logical address and so on. So I hope you have got the point. So that's why I have told you here that this router should configure to work at application layer, because if this router is configured to work at application layer, only then it can act as relay agent, and only then it will know about, okay, it is a query packet and so on. It knows about message. So since it knows, and it will send message this packet to server will reply, and router will reply to A and so on. Okay, so this was the basic idea about BOOTP. If you have any doubt, you can ask me. Okay, and I will jump to the next slide now. Done?
Done, sir.
Okay, so let me jump to the next slide. Next is DHCP, Dynamic Host Configuration Protocol. Dynamic Host Configuration Protocol. DHCP is the most advanced protocol. Okay, so what it is doing? So same, let me copy that out just to save the time. Everything will be same. Okay. Oops, copying will waste our time. Actually, it will your, let me duplicate it. Okay, yeah. Screen sharing will go on if I copy that out and so on. So now we are studying DHCP, Dynamic Host Configuration Protocol. Dynamic Host Configuration Protocol. Okay, these all things are same. Application layer, query packet, that will be there. Transport layer, UDP will be used. Port number is also same, 67. Okay, network layer, SIP, DIP, everything is same. Okay, now let me tell you that why this port number is same and so on. Okay, actually in networking we design protocols in such a way that they are backward compatible. Okay, so we design protocols in such a way that they are backward compatible. Okay, so DHCP is a more advanced protocol, and before DHCP we were having BOOTP. So if we are constructing a new protocol, that should be backward compatible. If it is not backward compatible, then you have to change entire technology. You might need another hardware also. Okay, and we do not want to just spend a lot of money on these silly kind of things. Daily basis technology is changing, so why you want to change hardware, why you want to do other techniques and so on. So better is you make the things backward compatible. That means DSCP, so everything will be same. So server will it is DSCP server. Okay, so if by chance this DSCP server is replaced by bootp server, then no problem. That means, let me tell you that thing, we have bootp server. Bootp server was giving reply to clients. Now we have just reversed the things. Bootp is replaced by DSCP, so now this DSCP will reply the clients. So just like that, you have a you have a you can say shop. You are the owner of the shop. Okay, and customers are coming. You are giving them services, like somebody needs bread, somebody needs dal, somebody needs something like that. You are giving them. Okay, now someday you sold your entire you can say your shop to someone else. Now someone else is the owner. Now it hardly matters to other customers. Now customers are coming, you are supplying bread, butter and so on, so now he will supply that thing. No problem in that. Okay, for customers you are the same, shop is same, everybody is coming here for bread and so on, so you are giving them. That is the basic thing. That is known as backward compatible things in networking. Okay, so bootp server is simply replaced by DSCP server. That's it. Everything will remain same. Client will remain same. Relay agent will be same. Everything will be same. Okay, so now question arises, why you have shifted from bootp to DSCP. So let me tell you that thing also. So bootp uses, okay, take snapshot. I will jump to the next slide. Done.
Yes, sir.
Okay, so now let me tell you that thing, that why we have shifted from this bootp to DSCP. What is the problem in bootp? Bootp was used in I think you have got it now. We have relay agents and so on, so bootp can be used in subnetting. Okay, bootp can be used in subnetting, no problem. Can be used in subnetting, which was not used in RARP. In RARP, it cannot be used in subnetting. That why it was absolute. Okay, it is not used nowadays, because in each subnet you have to install different servers. Bootp can be used in subnetting. That's why we have done this relay agent kind of thing and all. It can be used, no problem. Okay, now question arises that since it can be used in subnetting, then why we are shifting to DHCP? Now please listen here carefully. Okay, this is the most practical protocol which we are using nowadays. And after this DHCP, the you can say IP addresses are now in abundance. We are not saying you might say this. See, IPv4 to IPv6. Why we were shifting from IPv4 to IPv6? Because number of IPv4 addresses were very less, and number of computers were increasing day by day. That's why we shifted from IPv4 to IPv6. IPv4 is 32 and it is 128. 2 power 128 is very big number. Okay, 2 power 32 is actually very big also. No doubt, it is 4 billion. Okay, 4 billion is very big number. 2 power 128 is very high. Okay, and we were in transition from IPv4 to IPv6, but at that time DSCP started, and when DSCP started, everybody think that IPv4 is more than sufficient. We can work with IPv4 only. Okay, so and what DHCP is doing now, let me tell you that how IP addresses are why we are saying that IP addresses are in abundance and so on. Let me tell you that thing. So in DHCP there will be two databases. One is static, one is used for static mapping, and another is used for dynamic mapping. Okay, so by common sense I think you have got it now, what server might be doing. So it should have maintained a table. In that table it has put LA and PA. Okay, so it will match. See, whenever query packet comes to server will find the PA, search with PA, and accordingly it will reply LA to the machine, or to the machine which have query, which has sent query packet to this server. I think you have got it now. Actually, dogs are barking outside, and I think you might face some problems. Actually, I'm getting many distractions. Okay, so we can wait for at least 10 to 20 seconds at least, so that everything gets settled. Actually, I'm not able to concentrate properly. Actually, this is a very big problem in our society. Okay, yeah. So what we were studying. So we have so in server we should maintain a database. In that database, that means just like a table, physical address and logical address. So whenever query packet come to the server, it will match the physical address, and wherever matching is done, for example here itself matching is done, then it will simply reply the logical address. Okay, that is very simple scenario. This is generally done. Okay, but in today's world, since lot and lot of computers are coming, so what is done now, this is static mapping. Okay, this is static mapping. Okay, so now static mapping is not enough. If you have enough money, then you can go for static mapping. For example, you can get a static IP address. For example, if you got a plan of say BSNL, say 10,000 rupees per month, you will get a static IP address. Okay, so they will clearly mention, if you want a static IP address, then you should buy 10,000 per month plan and so on. And if you buy a plan for say 500 or 1,000, which normally users do, so you will get a dynamic IP address. Dynamic IP address means it will be given on lease or on demand to you. Okay, so we are using dynamic mapping. So whenever DHCP server gets a request, so it will first match the static mapping. So if it finds the match, then it will reply. If it does not find a match, then it have a pool of IP addresses. From that pool, it will give an IP address to you. Okay, it will reply, and it will make an entry in dynamic database regarding that IP address is given to this machine. Are you getting it? And this entry will remain there depending upon the, you can say, implementation, like for 10 minutes, 20 minutes, or half an hour, or 2 hours, and so on, like that. Okay, so that will remain. After that, it will be deleted. This entry will be deleted, and this IP address will be given back to the pool of IP addresses. Okay, and then if you still want internet, you will again request to DHCP server, and DHCP server will again see it will give you an IP address from pool of IP addresses to you, and so on. It will keep on doing like that. Okay, so on lease you will get an IP address. Okay, so if you keep your internet on, like I think you already 24/7 your router might be on. Okay, but if you regularly keep on using the internet, you might face some kind of glitch, like for 30 second or 20 second, internet will stop working after 1 hour or after 2 hour. You keep on continuously use your internet for 10 to 20 second, it will be gone. Why it has gone? Because now IP address will change. Okay, so your IP address will keep on changing. Okay, that is the basic scenario. Okay, so and let me tell you that thing. So in you are using Airtel internet connection, like mobile phones, you are using internet now in mobile and so on. So Airtel is one of your ISP, BSNL is one of the ISP. You know how many IP addresses they are having? You okay, they are using just 2 power 16 IP addresses. That means 65535. With 65535, entire India is using internet, Airtel internet. Okay, that is the beauty of the DHCP, dynamic host configuration protocol. Okay, so from mobile phone also, it will keep on disconnecting. Okay, just because dynamic IP is given to you. Okay, you are using just you are spending just 200 300 rupees per month, and you are getting daily 1 GB data or daily 2 GB data. How you are getting it? Okay, just because IP addresses keep on shifting from one mobile to another, from one mobile to another, and so on. They keep on shifting. Okay, that is the basic idea of DHCP. Okay, so what DHCP is doing, I just want to tell you just one thing. Everything is same, just like would be. The basic difference is DHCP is having two different server. One is used for static mapping, another is used for dynamic mapping. First of all, whenever request is received by DHCP, it will first check static mapping. If IP address is there, it will reply it. If IP address is not there, then from pool of IP addresses, it will assign one of the IP address to you, and it will make an entry in the dynamic database. Okay, and after depending upon the implementation, after depending upon the company policy, I should say, like Jio will give you for 30 minutes, Airtel might give you 80 minutes, and so on, like that. Okay, so depending upon that policy, this entry will be deleted time to time. Okay, so it's just like that. Whenever you are not using internet, immediately your IP address will be gone to pool of IP addresses, and whenever you start using internet, immediately from pool of IP address and IP address will be given to you. No doubt your internet is permanently on in your phone, but it will keep on toggling. Okay, the moment you stop using it, IP address will go to pool of IP addresses. It is just like that. Okay, so this is all about DHCP, dynamic host configuration protocol. It is the latest technology which is used nowadays. Okay, so they can ask you which protocol is used nowadays for LA to PA mapping. DHCP, dynamic host configuration protocol. Sorry, for PA to LA mapping, DHCP, dynamic host configuration protocol, PA to LA mapping. Okay, for LA to PA mapping, ARP is used nowadays. No problem, ARP is used. Okay, so let me tell you that thing in the next slide. Take the snapshot. Done.
Yes, sir.
Okay, so for LA to PA, ARP. For PA to LA, nowadays we are using DHCP, and boot P obsolete, it is not used, and RARP is not used. Okay, because boot P only static mapping, it can do only static mapping. DHCP can do both static also and dynamic also. If you have very high money, then you can go for static IP addresses also. Like you want to make your computer as a server, then you will go for static IP address. Like you want to you can say launch your website and so on, and you want to configure your computer as a web server. Okay, so then you need a static IP address. Then you will buy, you will have to buy a 10,000 or 5,000 per month plan. Okay, yeah, so DHCP can do static as well as dynamic. Boot P can do only static mapping. That was the basic difference between both. And RARP obviously it can do only static mapping, and but it is not used because it cannot be used in subnetting. In subnetting, RARP cannot be used. Boot P can be used in subnetting, no problem. But the problem is static IP address. DHCP obviously it can be used in subnetting, no problem, and it has two databases, static and dynamic. Okay, yeah, and they can ask odd one out also. Okay, for example, this type of question can be asked, odd one out. They will give you options like DHCP, boot P, and RARP. Okay, so you can take DHCP. Why? Because it is the latest protocol and it is using two different databases. Okay, so actually it is an ambiguous question, because you can take RARP also, because RARP is obsolete, it is not used nowadays. Okay, boot P is also obsolete, but it might be used, but actually DHCP is regularly used. Okay, RARP is obsolete, it is not at all used. Okay, yeah, so I think you have got it. So DHCP is basically used nowadays, and it is the most advanced version of protocol. Okay, you can take the snapshot. I will jump to the next slide. If you have any doubt, you can ask me. Otherwise, I will jump to the next slide.
Done, sir.
Okay. Hmm. Okay, so so next is ICMP. So this is over. LA to PA, PA to LA mapping, everything is fit and fine. Everything is over now. So see this. See the first slide. ARP is over. RARP is over. Okay. Next is ICMP. Let me start that ICMP. ICMP is Internet Control Message Protocol. Internet Control Message Protocol, ICMP. So I have told you in the previous lectures also, when I was giving you introduction of networking, ICMP, it is not error detecting or correcting protocol, it is error reporting protocol. It is error reporting protocol. Okay, it is error reporting protocol. Okay, so basically what it is doing, whenever intermediate router or destination host, or you can say the receiver, drop the packet, then ICMP error message will be sent to the sender informing that your packet has been dropped. please send it again. So it is simply error reporting protocol. You should know this thing. This is very, very important. And please write down one line which I have told you. Whenever datagram is dropped by intermediate router, whenever datagram is dropped by intermediate router or destination receiver, whenever datagram is dropped by intermediate router or destination receiver, then sender must be informed about packet has been dropped. Then sender must be informed about packet has been dropped. Packet has been dropped. This information is sent using ICMP. This information is sent using ICMP. Okay, so what is the direction of packet movement from ICMP side? So reverse, like from router to the sender or from receiver to the sender. Direction of movement is just reverse. Generally sender will send message to router, router will send message to receiver, but ICMP packets movement is completely opposite, from router to sender or from receiver to sender. Please note down, direction of packet movement for ICMP is from router to sender or receiver to sender. Router to sender or receiver to sender. Receiver to sender. Okay. So this is the basic introduction to ICMP. So whenever packet is dropped, ICMP message will be sent to the sender for whatever reason it has been dropped. So now I will tell you the reasons. What are the reasons of packet drop, and one by one we will study that. Take the snapshot. I will jump to the next slide. Okay. So broadly, okay, I think these are over. Slides. Let me. Okay. Yeah, so there are two category of messages. There are two category of messages. One is error reporting messages. Error reporting messages. And second is query messages. Query messages. Error reporting messages, let me tell you that one by one we will study. First is destination unreachable. Destination unreachable. Next is source quench. Next is time exceeded. Next is parameter problem. And the last is redirection. Okay, next is query messages. Query message always occur in pair, like echo request, echo reply. Next is timestamp request and reply. Next is address mask request and reply. And the last is router solicitation and advertisement. Router solicitation and advertisement. Okay, so these are the you can say important messages. So there are two category of messages: error reporting and query messages. One by one we will study them, and we will not go into format again and again. I'm repeating how destination unreachable message is given and so on. We are not interested in that. I will just tell you theory, one or two lines which are important for gate. That is more than sufficient. Okay, take the snapshot. I will jump to the next slide.
Done, sir.
Okay. So first is destination unreachable. DU, destination unreachable. Okay, destination unreachable message is again of two type. One is known as destination host unreachable, DHU, destination host unreachable, destination DPU, destination port unreachable. H means host, P means port. Okay, so first of all we should know what is destination host unreachable. Destination host unreachable means, see this is sender, this is router, and say this is receiver. Okay, so now sender has sent message to this router and router will send message to this receiver, na? So obviously if I talk in terms of datagram, then router cannot send datagram to this receiver, na? This datagram will be packed in frame. This datagram must be packed in frame, na? Frame means what? Header and trailer must be attached. So directly indirectly what we should know? ARP. Okay, so this router knows IP address of receiver, but it wants to know physical address of this receiver. So if once it knows physical address of receiver, only then it can make a frame and send this frame to this receiver. Okay, and what will be there in the frame? Obviously datagram. Okay, so we are attaching header and trailer, making this as a frame, and frame will be sent from this router to this receiver, but it can be sent only if in header you can say this router must know physical address of this receiver. If router does not know physical address of receiver, then what it will fill in the header. So directly frame cannot be made, it cannot be sent to the receiver. Okay, so now question arises, how this router will come to know physical address of receiver? It knows IP address, but it does not know physical address. So what we want? LA to PA mapping. LA to PA mapping, we need ARP. So ARP, what we do, ARP query packet is sent from this router to this receiver. Okay, rather ARP query packet will be broadcasted on entire network and receiver will reply it. Now let us assume this receiver is down, or you can say this receiver does not reply. Receiver has sent ARP query packet, receiver does not reply. There might be many reasons, like receiver is overwhelmed. Overwhelmed in the sense receiver has received lot of packets and it is processing them, that's why it does not able to reply it. Or receiver might be down also, like it shut down, we have shut down this receiver and so on. Whatever may be the case, basic thing is that receiver does not reply to ARP query packet. So what this router will do? Only option is router will drop the packet. Okay, it cannot keep this packet infinite time to itself, because obviously router also has a buffer. In that buffer it will store the packets. Okay, so buffer is limited resource, so why it will keep the packet here? It will simply drop it, and once packet is dropped, it will send ICMP, destination host unreachable message to sender, and sender will come to know that okay, my packet has been dropped, I will send it again. Okay, so DHU message will be sent from router to this sender. So I hope you have got it. If you want, then I can dictate 1 or 2 lines, otherwise it is okay. Please let me know.
Sir.
Is it okay?
Yes, sir.
Okay, so finally in just one line, if you want me to summarize, I will simply say router send ARP query packet to receiver, but receiver does not send reply to router. So since receiver does not send reply to router, router will drop the packet and send destination host unreachable message to the sender. Okay, that is DHU, destination host unreachable. Next is destination port unreachable. Port, I think you have got it from the transport layer. This term has been introduced. Now port number are there in transport layer. Okay, so what do you mean by destination port unreachable message? That is again very easy. So what we will do here, see, sender has sent the packet to the receiver. This is the sender and this is the receiver. Receiver has successfully received it, but I have told you, network layer will send the packet to the receiver. That means host to host delivery has been done, but packet has received the receiver. At receiver side, it is not sufficient that it has been received by receiver. It should be given to process. Actually processes are communicating. So this process to process delivery is given by transport layer. So now receiver has received the datagram, but it cannot be delivered to transport layer. That means it cannot be delivered to respective process because this process has not yet started. That might be the case, that this process has not yet started, or this process has crashed, or something might have happened. So obviously receiver will drop the datagram because it cannot send to transport layer, and then in case of that, receiver will send destination port unreachable message to the sender informing that your datagram has been discarded. So I hope you have got the point. Receiver has successfully received the packet. Now that means it has received the datagram, but this datagram should be forwarded to the respective process. That means it should be given to transport layer, but transport layer is not ready to receive the packet because corresponding process has been crashed or it has not yet started. So destination port unreachable message will be sent from receiver to sender because that datagram will be dropped by receiver. Okay, it has to drop now because it cannot be received by transport layer, then it will be dropped. And what message will be sent? Destination port unreachable. Okay, yes, another reason might be, I have told you when I was telling you about fragmentation, I have told you this is the sender, this is the router, and this is the LAN in which receiver is present. Okay, this is the LAN in which sender is present. MTU is different. So directly indirectly I want to say that this router want to do fragmentation. Okay, it want to do fragmentation of the packet, but do not fragment flag is 1. If do not fragment flag is 1 and it want to do fragmentation, because MTU here is less, so it will drop the packet and it will send destination port unreachable message to the sender. This is the another reason for DPU, destination port unreachable. Okay, why? Because fragmentation, router want to do fragmentation because MTU is different. For example, here MTU is 520 and here MTU is 200. So obviously router must do fragmentation, but do not fragment flag is 1. Do not fragment flag is 1 means packet will be you can say dropped. Okay, so I hope you have got it. You can take the snapshot. I will jump to the next slide. Let me put everything on one slide. Yeah, take the snapshot. I will jump to the next slide.
Done, sir.
Okay, so destination unreachable, two types: destination host unreachable, destination port unreachable. Destination port unreachable, two reasons I have told you. Destination host unreachable, I have told you. Okay, so you just note one or two lines because MSQ they might ask this question. Okay, let me jump to the next slide. So this is all about destination unreachable. Next is source quench. Source quench. Okay, source quench means, see this is the sender, this is the router. Okay, so router, I have told you na, it has a buffer. In that buffer it will temporarily store the packet and one by one it will do the processing and forward it. Okay, so obviously packet might come at router at very high speed, so obviously it will maintain a buffer. In that buffer it will store the packets. Okay, now assume this buffer is full. This buffer is full. Okay, and sender has sent the packet to the router. Now what router will do? Obviously it will discard the packet. Why? Because buffer is full. Since buffer is full, so it will discard the packet. And once packet is discarded, I have told you many times, whenever router discards the packet, ICMP message will be sent. Now question is which ICMP message will be sent? Source quench error message will be sent to the sender. Okay, SQ message will be sent to the sender. Okay, so now this SQ message sent to the sender will solve two purpose. It will solve two purpose. Okay, first purpose is obviously sender will come to know about that its packet has been dropped, it has to send again. Okay, so give info about packet drop. And second, since source quench message has been sent, so router is giving warning to the sender, please slow down, otherwise I will keep on dropping your packet. So next purpose is slow down. It is dictating sender to slow down, otherwise I will drop your packet. Okay, so two purposes it has solved. Source quench. So okay, so please take snapshot. I will jump to the next slide.
Done, sir.
Next is time exceeded. Time exceeded. So I think you have got it. Time exceeded is related to TTL field. I have told you router or even receiver. If router is doing from 1 to 0, it will drop the packet. If receiver is doing 1 to 0, it will drop the packet. Please watch the previous lecture if you have any doubt. TTL field I have properly cleared you. Okay, and if router has done 1 to 0, it will drop the packet and send time exceeded message to the sender. And if receiver has done it, it will also send time exceeded message to the sender. Okay, this is all about time exceeded. If you have any doubt, you can ask me. Otherwise, I will jump to the next slide.
No, sir.
Okay, so let me jump to the next slide now. Next is PP, parameter problem. Parameter problem. Parameter problem means, see, I have told you na SSR, strict source root. In today's class itself, we have studied this SSR. So, in case of SSR, if I have told you na, sender will list all the routers to which packet must be, you can say, if this path should be followed, then sender will put IP addresses of all these three routers. If by chance packet is received by some other router, like this router must send packet here, but if by chance this router send packet to this router, now this router will check that SSR option is there and my IP address is not in the list, so I will drop the packet and it will send PP message to the sender. This is one of the reason for SSR. Okay, so and another reason is PP. I think parameter problem, you have got it. This router has I have told you na what we were maintaining, checksum we were maintaining na. And so checksum has been you can say recalculated. I have told you each and every router will recalculate the checksum. Okay, so checksum has been calculated and it is not coming as expected. That means there is some error. So if there is an error, router will drop the packet and it will send parameter problem message to the sender. Okay, so checksum error or SSR, two reasons for parameter problem. Okay, so you can take the snapshot. I will jump to the next slide.
Yes, sir.
Okay, next is redirection. Redirection. This is the last message. Redirection means I have told you that router obviously have routing table because they want to forward the packet. Similarly, computer also, whatever computer is connected to internet, it also has an you can say routing table. Okay, and if you want to know your routing table, you can use netstat rn option in command prompt in CMD. Type CMD in Windows run. Okay, Windows key plus R key you type. Okay, and you can input CMD here. Okay, so command prompt will be opened. In that command prompt, you type netstat -rn. Hyphen means it is an option. Okay, this is a command netstat rn, and it will give you the entire routing table of your machine. Okay, so you can check that out. Okay, so I want to say that not only router, each and every computer connected to internet also has a routing table. Okay, so each and every computer connected to internet has routing table. Okay, yeah, that's it. Okay, so now imagine a scenario. We have a LAN here and we have a computer A. Okay, and this LAN is connected to another LAN via router R1, and in this LAN we have computer B. So this is LAN 1, this is LAN 2. Okay, and this LAN 1 might be connected with other routers and other LANs and so on. Okay, it might be connected, and this LAN is connected with router R2, and this router R2 is connecting this LAN with entire internet. Okay, so the router which is connecting LAN to entire internet, that router is known as default router. So what is the default router? Default router for a LAN is the router which is connecting that LAN to entire internet. Are you getting it? So R1 is not default router because R1 is connecting this LAN with another simple LAN 2. Okay, and this router is connecting with another LAN and so on. Okay, so now assume A want to send message to this B, and I have told you every computer connected to internet has a routing table. So same is the case with computer A. Computer A also has its own routing table, but in that routing table it will have only one entry initially, that is of default router. Okay, because it is connecting this LAN to the internet, so this computer A will have only one entry, that is for default router only. So now what it want to send message to B, so it must have forwarded packet to R1, but since in its routing table it has no entry for R1, it will send packet to R2. So now what R2 will say? R2 will say, okay, I am sending your message to R1 and R1 will forward the packet to B. It's okay because you have done for the first time. I am allowing it, but I am giving you warning that please do not send message to me again. You should send message to R1 only. Okay, so that is redirection message. So R2 will send redirection message to A, and this A will update its routing table and store IP address of R1, so that from the next scenario or for the next time A will send message. If A want to send message to B, it will directly send to R1. It will not send message to R2. Okay, that is the basic meaning of redirection. So in redirection, please note it, packet has not been dropped, packet has been transferred, and still redirection message is sent to A, giving information that I have transferred your packet, but this was first and the last time. Please do not send message to me again. I am very busy person. You should directly send message to R1. R1 will forward your message to B. Any doubt here?
No, sir.
Okay, so this is the redirection message, and redirection message is completely different for other messages, because every time, see this, parameter problem, packet was dropped, time exceeded, packet was dropped, source quench, packet was dropped, destination unreachable, packet was dropped, everywhere packet was dropped. In redirection, packet is not dropped. So odd one out, they can ask this way. Okay, so they can say odd one out, so they will say source quench, parameter problem, destination unreachable, and redirection. So what is the odd one out? Redirection, because everywhere packet is dropped, but here packet is not dropped. Okay, yes, so you can take the snapshot if you want me to dictate some notes. Otherwise I think it's okay, it is a recorded session. If you want to make your notes, you can make it. We should not waste time here. Okay, so take the snapshot. I will jump to the next slide. Okay, yeah, so the next is query message. So all the messages are over, you can please check it out. Destination unreachable is over, source quench is over, time exceeded, parameter problem, redirection, now everything is over. Now we are jumping to echo request and echo reply, that is query messages. Echo request and echo reply. Echo request and echo reply. Okay, so actually these are messages which are used to check the communication between sender and receiver. That means, see this, sender and this is the receiver. Okay, so it will send echo request here to here, finally receiver will receive it and it will simply reply. So if sender has sent echo request and it has got reply from the receiver, that means what? All the routers in between, they are forwarding the packet properly. So basically it is used for network diagnostic purposes. Network diagnostic purposes, or you can say debugging or and something like that. Okay, so if sender has sent echo request and it has got reply, that means all router in between are working properly. Okay, yes, and the best example which is using echo request and echo reply is your ping command. Ping command uses this echo request and echo reply message. Okay, ping is packet internet gopher. Packet internet gopher. Gropher is an English word. Gropher means you are finding something in a dark. Okay, like you are in a dark room and something fell down, like your something like, and you are searching that thing. Okay, that is gropher. Okay, gropher means you are finding something in a dark. That is the basic meaning. Okay, so packet internet gropher. Internet gropher. That is the full form of ping command. Packet internet gopher. And this question has been asked regarding ping command. It works at network layer only. That is, it is not client server application. Okay, it work at network layer only. It work at network layer only. Okay, and so directly, since it is working at network layer, so obviously it is not a client server application. Not a client server application. They have asked, they have given few options. Which the following is not client server application? Ping command is not a client server application. Okay, so they have given option like DNS domain name system. I will tell you, it is client server model only, DNS. Okay, and many other options were there. Don't worry, we will tell you when we will jump to application layer. If I will tell you here itself, it is of no use. You might not be able to understand the question. So better is in application layer, I will tell you these things. Okay, so you should know just one thing. This question has been asked. Ping command, it works at network layer. It is not client server application. That's it. Okay, yeah. So you can take the snapshot. I will jump to the next slide.
Done, sir.
Okay, next is timestamp request and reply. Timestamp request and reply. It is used to synchronize the clock of sender and receiver. Okay, it is used to synchronize clock of sender and receiver, because sender might be in India and receiver might be in USA. So you want to synchronize their clock. For that, timestamp request and reply messages are used. Okay, actually it is not used nowadays. Nowadays we use NTP, network time protocol. Okay, NTP is used nowadays, network time protocol. It is not required for gate, just for the information I have told you. So time, and they will just ask one or two line. Timestamp request and reply, for what purpose it is used? It is used to synchronize the clock of sender and receiver. That's it. Okay, take the snapshot. I will jump to the next slide.
Done, sir.
Okay. Third is address mask request and reply. This is important. Many times question have been asked in gate from this topic. So address mask request and reply. What does this mean? So see this. This is a computer A in a LAN. And here we have a router and here we have another LAN. So now this A computer knows its own IP address. Obviously it is connected to internet. It's know its own IP address. No IP address. Okay, but A does not know net mask, or you can say address mask. One and the same thing. Address mask, net mask, one and the same thing. Address mask it does not know. Okay, net mask does not know. So it will send address mask request to the router, and router will send its address mask to A. Okay, address mask of this LAN, in LAN to which it is connected. Net mask is for LAN. Okay, so net mask does not know net mask of its LAN. Net mask of its LAN does not know. Okay, so it will send address mask request to the router, and router will send address mask reply. Okay, so now question arises, after all, why it need to know the net mask? Okay, what is the use? So use is that, see carefully, there is a computer B in this network and computer C is in this network. So now if A want to send a message to B, it can send the message directly because it is in his own LAN. But if it want to send a message to C, it first has to send a message to the router, and router will send a message to C. Are you getting it? So A cannot send a message to C directly. but A can send a message to B directly. Okay, so now how A will come to know that B is in my network, or it is not in my network? If B is in his own network, then A will directly say to ARP that find the physical address of B. So A will send query packet in entire LAN. B will reply the physical address to A, and simply A will send frame to B directly. Okay, so there is no problem at all. Are you getting it? If you have any doubt, you can ask me. I'm just building the base of numericals which have been asked in GATE. Please let me know if you have any doubt.
Understood, sir.
Okay, so so if A knows that B is in my network, so A will send a query message, ARP query message to entire LAN, and B will reply, and A will come to know physical address of B, and once it know physical address, it will send the frame to B. So game over, everything is fit and fine. Okay, but if it want to send a message to C, and it come to know that C is not in my network, then it will send query message to the router saying that please send me your physical address. Router will send physical address. That means A will send a query message. It will be broadcasted in entire LAN, and router will reply its physical address, and A will send a packet to router. Then router will again do ARP query packet, and it will send to C and so on. It will be done like that only. Okay, so the basic thing is that router will be involved. Okay, A will send packet to router, router will send packet to C, but to B it can directly send. So now obviously question arises, how A will come to know that B is in my network? So on that topic, GATE have been asked questions. So let me tell you that. Okay, so how A come to know about B is in my network? Once it knows that B is in my network, it can send the packet directly. I have told you many times. Okay. So now question is how A comes to know that B is in my network or not. So directly and indirectly I want to tell you that how this is known as direct delivery. A will send message to B, that is direct delivery, and A send message to C, that is indirect delivery, because A will send message to router, router will send message to C. So they can ask question like this also, that how A come to know that delivery is direct or indirect. Okay, so if A is sending message to B, this is known as direct delivery. This is known as direct delivery. And if A is sending message to C, this is known as indirect delivery. So they can twist the question and they can ask like this also, how A will come to know that delivery is direct or indirect. Okay, they can ask like this also. Okay, so now question is how it will come to know. So for that it will apply the net mask. Okay, how it will be done, let me tell you that thing. For example, so I am just solving gate numerical only. Okay, so B IP address is 130.40.50.60. Okay, A IP address is say 130.40.60.70, and A want to send a message to B, and it want to know whether delivery is direct or indirect. That means it can send message directly to B or not. It want to check whether B is in my network or not. One and the same thing. So first of all, A will send address mask message, address mask request to the router. Router will give reply, address mask reply, and let us suppose address mask what router has given is 255.255.0.0. So now what A will do? A will apply this net mask or address mask and it with its own IP address. So 130.40.60.70, 140.60.70, 255.255.0.0. I think you have got it. We will get this. So A comes to know that net ID of my network is this. Now it will apply the same address mask or net mask with IP address of B. So what it will do, let me copy it out just to save the time. So what was the IP address? 130.40.50.60. I think it's very obvious. 50, 60. So I think you have got it. We will get this only 130, 40, 00. This is the net ID. So now A will compare that my net ID is this, and the network to which B is connected, that net ID is this. Both net ID are same. That means it will say delivery is direct. Delivery is direct. That is, B is in my network. That is, A will say B is in my network. Now since B is in my network, so it will simply send this IP address to ARP. Okay, so A give this IP to ARP. Okay, and then ARP will give query packet, reply, and so on. It will do all the things. Okay, and finally it will get physical address of B, and then A will send frame to B. That's it. Okay, A will give B IP. A give B's IP address to ARP. Then ARP will send query packet, and so on. Everything will be done perfectly. So this question has been asked in GATE many times. How A will think that B is in my network. A will don't think B is in my network, and so on. They will give this option. So you will say A will think that B is in my network only. Any doubt here?
No, sir.
Okay. So now let me give you a slight more you can say difficult question. Take the snapshot. I will jump to the next slide.
Yeah, sir.
Okay. So they will say 130.40.140.60. This is a gate question. /16. IP address of A is this. So directly slash means classless addressing. Okay, it is not classful. So do not say it is class B and so on. Okay, and B IP address is given as 130.40.200.40/18. Okay, A IP address is this, B IP address is this. So they are giving you option. A will think that B is in my network. B option. B will think that A is in my network. C option both, D option none. This is a gate question. So you might say, sir, when A will think that B is in my network, obviously B will think that A is in my network. Both will be the option. But no, it is not the case. Okay, so I have told you the procedure how you will check. A will think that B is in my network. So what it will do? First of all, A will apply this net mask is /16. /16 means what? 255.255.0.0. So it will apply this net mask with its own IP address, and it will try to find the net ID. Now it will apply the same net mask with this IP address, and it try to find the net ID. If both net ID will be same, then A will say, okay, B is in my network. And what B will do, it will apply this net mask with its own IP address, and it will find the net ID. Now it will apply this net mask with IP address of this, IP address of A, and it will try to find the net ID. If both will be same, then B will say, okay, A is in my network. Otherwise, B will say, no, A is not in my network. I have told you the procedure. Now let us implement it on a faster manner. So A will think. A will think. So for that I am doing what I will say 130.40.140.60/16 na. So 255.255.0.0 it will do, and it will get 130.40.0.0. So net ID of A is this. Okay, now if net ID of B, for that it will apply the same net mask with IP address of B. So let me do that. Let me copy it out just to save the time. Yeah. So what is the IP address? 130.40.240. So same, it will get same. So A will think, finally what I will say, A will think B is in my network. B is in my network. So are you getting the procedure? What is the procedure? A will apply its own net mask with its IP address to get net ID, and the same net mask will be applied with IP address of B to get net ID of B, and A will think that B is in my network because net ID are same. Now what about B? What about B? So what B will do? I will copy it out. So B will apply its own net mask. So what is the number? Slash 18. Slash 18 means here what I will get? 128 plus 64, that is 192. 192. Okay, now because of 192, I think you have got it. In 140, 128 will be 1, but after that it will be zeros, and here 192 first two are ones. So obviously what you will get? 128. Try to imagine. You will get 128. And here what you will get? Here what you will get? 192. Okay, acha, 130, 40, 240. So in case of 200, first two are ones. First two are ones, so obviously what you will get here? 192 itself. So this was the IP address of B, this was the IP address of A, and this net mask is of B only, B's network. Okay, so now B will find its own net ID. B net ID is this, and now B is applying its own net mask with IP address of A to find the net ID, and this net ID it has got. So these two net ID are different. So clearly B will say A is not in my network. B will say A is not in my network. So obviously what is the answer? A is correct. B is false. This is a great question. So I think you have got it, how we will solve this type of question.
Yes, sir.
Okay, so just for the sake of practice, I can give you one question as your homework. You can take the snapshot. I will jump to the next slide.
Done, sir.
Okay, so 130.40.60.20/24, 130.40.60.10/25. Okay, so A and B, same options you can copy. Okay, so this is the homework. A will think that B is on same network, B will think A is on same network, both or none. You can do it yourself. Very, very easy. I think there is no need to explain. If you have any doubt or something, I can solve it. Please let me know.
No, sir.
Okay, so take the snapshot. I will jump to the next slide.
Done, sir.
Okay, so third message I think we have done, address mask request and reply. Last I think we have router solicitation and advertisement. Router solicitation and advertisement. So what is this? So solicitation is an English word. Solicitation means asking. Advertisement, I think you already know. We do advertisement and so on, informing something. That is advertisement. Okay, so now let us imagine we have a LAN, and here we have a computer A. Okay, and router is connecting this with LAN number 2. This is LAN 1 and this is LAN 2, and here we have a computer B. Okay, and this is the default router which is connecting to the internet. Okay, this router is connecting this LAN with the internet. So this is the default router. Okay, so now chances are there, this is the R1, this is R2. Now A want to send a message to B. First of all, it will send message to R2. R2 is the default router, so it will send message to R1 and it will give warning to A that please do not send message to me because I'm very busy. Send it to R1 because B is connected to R1. That was redirection message which I have already told you. So now what about this scenario? See this. If this router R1 fail, so A will keep on sending message to R1. Okay, assuming that B will receive the message but R1 is fail. Okay, so what is the solution? So how A will come to know about all these things? So in place of sending message to R1 blindly, first of all it will send router solicitation message. That means asking, are you alive or not? So router will do advertisement that yes, I am alive, you can send message to me. That is router solicitation and advertisement. That was the rough idea. What exactly we are doing? Whenever a machine do router solicitation, so whatever router receives that solicitation message, they will advertise their routing table, or they will broadcast their routing table to all the computers, informing that see, we are alive and we are connected to these and these machines, you can send us messages and so on. Okay, so if this router is if this router is sending its own routing table, that means what? It is advertising itself. See, I am connected with these machines, you can send me message and so on. Okay, so that is advertisement. Advertisement means what? You are informing about your products. You have made a product and you are informing everybody that see this, I have made a product, you can buy that and so on. So that is the case here. R1 is sending its routing table means R1 is informing everybody, see this, I am connected to these machines, my network is that much big, you can send me messages. That is the basic meaning of advertisement. Okay, so this is router solicitation and advertisement. And even sometimes, even if a router does not get solicitation message, they can time to time they can send this advertisement to every other computers in the network. Okay, just to informing that we are alive, you can send us messages. Okay, this is all about router solicitation and advertisement. Any doubt here? Okay, so I hope you have got it. So let me jump to the next slide. I'm audible, na?
Yeah, sir.
Okay. Okay, so this is router solicitation. So that's it. Last was IGMP, Internet Group Message Protocol. So it is not required for GET. We will not dig deep into it. It is just for multicasting. You should know just one line. IGMP is used for multicasting. That's it. Okay. Yeah. So that's it. So here we have completed all the 4 supporting protocols of IP. Okay. And next is delivery and forwarding. Take the snapshot. I will jump to the next slide.
Done, sir.
Okay. So next topic is delivery and forwarding. Delivery and forwarding. Okay, delivery, forwarding, and routing. I will write all the 3 topics at the same time. Delivery, forwarding, and routing. Okay. So most probably this is the last topic of your network layer, but actually it is very huge topic. Okay, if it is completed, then your network layer is completed. Then we have only transport layer and application layer. Okay, yeah. So first of all, we should know what is delivery. Delivery means you are simply delivering the packet. Okay, so delivery is of 2 type: direct delivery and indirect delivery. Okay, so if I want to show you with a picture, you will get more clarity. One picture is worth 1,000 words. So in place of giving words, better is the picture. So sender wants to send message to receiver. So first of all, sender will send message to this router. Obviously, it want to send to receiver, but it has sent to router. It is indirect delivery. This router to this router, indirect delivery. This router to receiver, this is direct delivery. Okay, so whenever packet is sent from sender to receiver, it will have exactly one direct delivery. For example, sender and receiver are directly connected, so you will do direct delivery, just one direct delivery. And indirect delivery can be any number. Okay, so if you have say n routers in between sender and receiver, you have n routers, then there are n indirect deliveries and one direct delivery. Okay, they can ask this. Okay, so if n routers, or you can say S and R are connected, or you can say between S and R we have, between S and R we have n routers, then n indirect delivery and one direct delivery, an indirect and one direct delivery. Okay, so I think you have got it. This is all about delivery. Next is forwarding. Forwarding means delivery is over. Okay, delivery is very simple. Next is forwarding. Forwarding means to place the packet in route to destination. Okay, so we are placing the packet in the route towards the destination. That is forwarding. Let me jump to the next slide. Take snapshot. Done. Okay, so I hope you have taken it. So I'm jumping now. So next is forwarding. Forwarding means to place the packet in its route route to destination. That is the basic meaning of forwarding. Okay, so how forwarding is done? Forwarding is done with the help of routing table. Forwarding is done with the help of routing table. Who is having routing table? Both host as well as router. Both have routing table. Just now I have told you. Okay, so how they will find deliveries, direct or indirect? We have told you we have two types of delivery, direct and indirect. How router or host will come to know that delivery is direct or indirect? It will come to know by applying the net mask. Okay, so they will apply their own net mask with the IP address to find the net ID. Okay, if net ID is same, delivery is direct, otherwise it is indirect. I have told you, see this. Actually, I should not repeat all these things again and again. I have just told you this thing. Okay, delivery is direct or indirect. Where, yeah, this is direct delivery, this is indirect delivery, and how you will come to know this. So delivery is direct, that is A will say B is in my network, and A will give IP address to IP to ARP and so on. I have told you all these things. Okay, so just now I have told you. Okay, so from the net I will just write one line. Okay, so this host or router come to know about delivery is direct or indirect. Delivery is direct or indirect by applying net mask. Okay, by applying net mask. Roughly I have written it. Proper procedure I have told you a few minutes back. Okay, so this is all about forwarding. So next is we will study some forwarding techniques, like how actually forwarding is done. I have told you now with the help of routing table. Okay, so forwarding is done with the help of routing table. Now question arises, how this routing table look like? Okay, that is the basic thing. So now question arises, what are the content of routing table? Content of routing table. So slowly I will dig deep into this topic, that is how routing table was developed and so on. So time is up. In the next class we will start this topic, that how this routing table was built and so on. Okay, and once we come to know about how this routing table look like, then we will start few gate questions regarding they many times gate have been asked question. Routing table is given to you. Okay, and they will say this packet has come and you have to see the destination IP address, and accordingly you will see the destination IP address in the table, and they will mention the port number, like port number 10, or you can say interface of the router is 10. So from the router you will say from the port number 10 or interface number 10 you will forward the packet. This type of question I have been asking it many times. Are you getting it? A routing table will be given and destination IP address will be given. They will say from which port or from which interface of the router this packet will be forwarded. This type of questions are very famous in Git. So of course, before studying these, we should know what is the content of routing table and all. Slowly we will build these concepts in the next lecture. Okay, so now very important questions are coming. These all are, I should say, these all are lollipop type of question or toffee questions, because very easy. Once you know the concept, one time you have to listen. Once you know the concept, you will be able to solve all the Git question very easily. Okay, yeah, so that's it. So we will wind up the class here itself. In the next class we will start from here. Okay then, thank you so much. Bye bye, good night.